Do you know that hundreds of pounds of orange peels and pulp are dumped in a national park in Costa Rica? Not as illegal dumping, but as part of a sanctioned, experimental effort to restore degraded land? Approved by the forest protectors, it became one of the most controversial environmental experiments in history. Over time, 1,000 similar truckloads dumped 12,000 tons of rotting orange waste onto the landscape. The project ignited outrage in the local community, sparked lawsuits from competitors, and divided environmental groups. Just as it gained momentum, Costa Rica's Supreme Court shut it down, and it was forgotten for nearly 20 years. This is the story of waste, legal battles, and an astonishing forest recovery that stunned scientists. It began with two ecologists, a bold business deal, and a mountain of orange peels poised to challenge everything we thought we knew about restoration. Their idea risked either transforming ecological science or triggering disaster. They were about to find out which. Costa Rica covers just 0.3% of Earth's surface, yet holds 6% of the world's biodiversity. Known globally for its eco-friendly image, it's a country celebrated for lush rainforests, sloths, toucans, and sustainability. But beneath this reputation lies a stark contrast. Decades of deforestation and cattle ranching had turned vast areas, especially in Guanacaste province, into barren pastures. The forests were gone, replaced by an invasive African grass called jaragua. Originally introduced decades earlier, jaragua proved nearly impossible to eradicate. It overtook native plants, forming a monoculture that stripped away biodiversity. Worse still, during the dry season, jaragua became potent wildfire fuel. Fires would sweep the region, destroying any chance of tree regrowth. Once the rains returned, the grass came back even stronger, halting natural forest recovery. The soil, too, had suffered. Generations of trampling and overgrazing compacted the ground, draining it of nutrients. From afar, the land appeared green, but up close it was an ecological dead zone, hard-packed, depleted, and unable to support regeneration. Despite Costa Rica's green image, large swaths of its landscape had been rendered biologically lifeless. Daniel Jansen and Winnie Hallwachs, a husband and wife team of Princeton-trained ecologists, had spent their careers protecting tropical ecosystems, particularly in Costa Rica. Since the 1970s, they had worked as researchers and technical advisors at the Área de Conservación Guanacaste, one of the country's most vital protected areas. Unlike academics observing from afar, they were on the ground, witnessing firsthand how degraded cattle pastures were spreading and threatening the forests they were trying to save. Jansen was deeply focused on the complex interactions among plants, animals, and soil that made tropical ecosystems thrive. Hallwachs concentrated on the real-world hurdles of conservation in a country where livelihoods depended on land use. Together, they observed a disturbing pattern. Even as they protected forested zones, the surrounding lands were becoming ecological dead zones, unable to recover, dominated by invasive grasses, and cut off from regeneration. This fragmentation threatened to isolate and ultimately destabilize the forest itself. They had tried traditional restoration methods, planting native trees, removing invasive species, and using equipment to loosen compacted soil, but none succeeded. Jaragua grass returned relentlessly, soil stayed poor, and new trees barely survived. The couple realized that without a bold shift, biodiversity would continue its steady decline. Then came an unexpected development, news of a new orange juice factory opening near the conservation area. Where others might have seen a looming threat from industry, pollution, traffic, and pressure on the forest, Jansen and Hallwachs saw potential. With little left to lose, they began exploring how industrial waste could offer a radical solution to Costa Rica's growing ecological crisis. In 1997, Del Oro opened a massive orange processing facility along the northern edge of the Guanacaste Conservation Area, investing heavily in Costa Rica's expanding citrus industry. The plant processed thousands of tons of oranges for export, but faced a major challenge: orange juice production uses only half the fruit. The leftover peels, pulp, and organic waste piled up daily, creating logistical and environmental headaches. Disposal options like landfills were costly and unsustainable. Burning caused pollution and complaints. Waste lagoons attracted pests and emitted strong odors. Jansen and Hallwachs saw an opportunity. They proposed a solution. Del Oro could dump its orange waste in the conservation area, in exchange for donating undeveloped forest to expand the protected land. It was mutually beneficial. Del Oro reduced disposal costs, and the park gained more territory. However, strict conditions applied. Only citrus waste could be used, no other agricultural byproducts. The oranges had to be pesticide-free, and the peels processed to remove D-limonene, a natural herbicide that would otherwise hinder plant growth. Dumping was restricted to degraded pastureland, already damaged by years of cattle grazing, with no impact on existing forest or pristine habitats. The goal was ecological restoration, not disruption. Del Oro accepted the terms. In August 1998, they formalized the agreement, committing to transfer nearly 3,000 acres of forest to the conservation area over 20 years. In return, they were permitted to deposit their treated orange waste on carefully selected, degraded land. What followed would be remembered as either a groundbreaking experiment in ecological recovery or a risky gamble that challenged conventional thinking about industrial waste and environmental restoration. In early 1998, a highly unusual convoy began daily trips to the Guanacaste Conservation Area. Over time, 1,000 trucks transported roughly 12 tons each of processed orange waste from Del Oro's facility to a designated 7-acre plot of degraded pastureland. The material, mostly peels and pulp, had been treated to remove harmful oils, but it was still dense, sticky, and odorous. As the trucks arrived, they dumped their loads with a wet, squelching sound that filled the quiet landscape. The smell of rotting citrus was so intense it could be detected over a mile away. During this initial phase, the site appeared to be in worse condition than ever. The orange waste formed uneven mounds across the former grassland. Flies clustered in black clouds and birds circled curiously overhead. Small mammals stayed back, unsure of the change in their environment. Locals and even Del Oro employees questioned the logic behind this project. The area looked like a dumping ground, not an ecological experiment. But Jansen and Hallwachs remained confident. They understood that transformation takes time. Slowly, the orange waste began to decompose. As it broke down, it formed dense, nutrient-rich compost that infused the soil with nitrogen, phosphorus, and potassium, the same nutrients typically delivered through synthetic fertilizers. This natural decomposition process created a thick layer of organic matter, improving the soil's fertility dramatically. Crucially, the compost also smothered the invasive African grass that had long dominated the region. Starved of sunlight, the grass died back, its roots weakening until the monoculture collapsed. Without competition, native plants began to return. By the end of 1998, the site had undergone a dramatic shift. The rancid piles of citrus waste had transformed into dark, fertile compost. The smell of decay had vanished, replaced by the earthy scent of healthy soil. Green shoots began to sprout, clear signs that native vegetation was taking hold. In total, Del Oro had deposited over 12,000 tons of processed waste. The company was saving on disposal costs, and the land was beginning to recover. Jansen and Hallwachs were cautiously optimistic. But not everyone shared their enthusiasm. Unknown to them, their work was being monitored closely, and someone was strongly opposed to what they were doing. Enjoyed the video? Before we continue, don't forget to ring the bell, share it with your friends, and hit that subscribe button if you haven't yet. It truly helps me out, and I promise to bring you even more awesome content. Ticofrut, Del Oro's main competitor in Costa Rica's orange juice industry, was outraged by the waste dumping deal. The two companies had long competed over market share, processing capacity, and access to top orange groves. From Ticofrut's perspective, Del Oro had secured an unfair advantage. While Ticofrut spent hundreds of thousands of dollars on waste treatment facilities and disposal, Del Oro was eliminating its waste for free while earning praise for its environmental efforts. To Ticofrut executives, this wasn't innovation, it was cheating. They had invested in proper infrastructure out of environmental responsibility. Now, their rival's shortcut made those investments look wasteful. Determined to fight back, Ticofrut hired lawyers and launched an aggressive public relations campaign aimed at shifting public sentiment against the project. Rather than framing the issue as a business dispute, Ticofrut's campaign focused on environmental harm, a message likely to resonate with Costa Rica's eco-conscious public. They labeled the dumping site a mountain of rotting waste in a national park. Brochures featured dramatic photos of the orange waste and claimed the project was damaging the country's environmental reputation. They alleged that toxic citric acids and oils, especially D-limonene, posed long-term risks to soil and water. They warned of infestations by the Mediterranean fruit fly, a destructive invasive species that could endanger agriculture nationwide. The campaign gained traction quickly. Editorials began criticizing the project. Environmental groups previously uninvolved started voicing concern. Local farmers feared crop losses from pest outbreaks. Even government officials who had initially backed the initiative began reconsidering their support, unable to ignore the imagery and warnings Ticofrut was circulating. Not content with a PR war, Ticofrut escalated its response. In late 1998, the company filed a lawsuit to halt the project. Their legal challenge was comprehensive. First, they argued that dumping any waste in a national park was unlawful, regardless of intent. Protected areas were meant for preservation, not industrial experiments. Second, they claimed the Del Oro agreement violated fair competition laws, giving one company free disposal while others bore full costs. Finally, they warned that approving such a project would set a dangerous precedent, opening the door for other industries to justify dumping in protected areas under the pretext of restoration. The legal case quickly became one of the most high-profile environmental battles in Costa Rica's history. On one side were Jansen and Halwax, supported by Del Oro and environmental organizations like the Rainforest Alliance. Opposing them was Ticofrut, joined by business interests wary of regulatory precedent and environmental groups concerned about protecting national parks from industrial activity. Scientific evidence strongly supported the project. Independent studies by the Rainforest Alliance found that the orange waste restored degraded soil without environmental harm. Soil tests showed improved fertility and no signs of toxicity. No increase in pests or damage to wildlife was observed. Del Oro provided documentation proving compliance with all agreed conditions: pesticide-free oranges, processed waste with harmful oils removed, and dumping confined to already degraded land. Yet public opinion turned against the project, and scientific validation proved insufficient. The case dragged on for months, drawing media attention and diverting resources from conservation work. Despite favorable findings from environmental experts, Costa Rica's Supreme Court ruled against the project. The judges acknowledged the restoration potential but prioritized the legal precedent, fearing it would invite similar proposals in other protected areas. The 20-year contract between Del Oro and the conservation area was voided. No further dumping was permitted. The site, where 12,000 tons of orange waste had already been deposited, was placed under strict non-interference. No monitoring, additions, or modifications were allowed. The regional environmental official who had worked on the project lost his position. Del Oro incurred over $100,000 in legal fees and was left with a waste disposal problem. For Jansen and Halwax, the ruling was a major defeat. Years of scientific effort were undone by legal constraints. The site was marked with warning signs and left untouched, its future uncertain. Time passed. The experiment faded from public memory. Climate change escalated into a global emergency. Environmental restoration grew into a multi-billion-dollar industry. New projects emerged worldwide, but most were costly and slow. The orange peel experiment became a legal case study, viewed by some as a narrowly avoided disaster, and by others as a promising innovation cut short by politics and corporate rivalry. But no one knew what had become of that 7-acre site in Guanacaste, where 12,000 tons of citrus waste had been left to nature. In 2013, Daniel Jansen was contacted by Timothy Truer, a Princeton graduate student researching innovative forest restoration methods. Truer had heard references to the long-abandoned orange waste experiment and was eager to learn what had become of the site. Initially, Jansen was hesitant. The project had been one of the most disheartening setbacks of his career, and he had moved on. But Truer was persistent, and Jansen eventually agreed to share the GPS coordinates of the experimental plot. When Treuer arrived in Costa Rica, he expected to find a barren 7-acre site, marked by the large yellow sign described in earlier accounts. He assumed the land would still show signs of degradation, perhaps with some regrowth. Instead, he found nothing resembling the wasteland he anticipated. Treuer spent hours driving along the dirt access road, searching for the yellow sign. The GPS indicated he was in the correct location, but there was no visible marker. Puzzled, he contacted Jansen, who provided more precise directions and confirmed the sign should be unmistakable. A week later, Treuer returned with a research team and began a thorough search on foot. To their surprise, they discovered the area was now a dense, thriving forest. Towering trees formed a closed canopy, and thick undergrowth made movement difficult. The former pasture had become a mature ecosystem, unrecognizable from photos of the original dumping site. For nearly an hour, the team searched for any sign of the original plot. Eventually, one member spotted a hint of yellow beneath the vegetation. After cutting through vines and foliage, they found the edge of the old sign, once clearly visible from the road, now buried in plant growth and nearly impossible to see unless standing next to it. The forest was so developed that some tree trunks required several people to encircle. The transformation was so extensive that only the GPS coordinates confirmed they were in the correct location. A site once written off as an ecological failure had undergone a dramatic and unexpected recovery. Treuer and his team recognized the significance of what they had found, but anecdotal observations were not enough. To validate the transformation, they needed measurable, scientific evidence, data that could be independently verified and used to support broader conclusions about large-scale ecosystem restoration. What's your reaction to the discovery that the abandoned orange waste site had transformed into a thriving forest after being left untouched for 16 years? Let us know in the comments below. Over the next 3 years, the research team conducted the most detailed study to date on the use of agricultural waste for forest restoration. They measured soil composition, tree species diversity, biomass accumulation, canopy density, and carbon storage. The orange waste site was compared to untreated plots of degraded pastureland directly across the road. The findings were striking. The treated site had 176% more above-ground biomass than the control area. While the untreated land supported only 8 tree species, the orange waste plot had 24. The surrounding grassland remained sparse and stunted, while the experimental area had become a dense forest. Soil tests explained the difference. The decomposed orange waste had produced highly fertile soil. Nitrogen levels were significantly elevated. Phosphorus and potassium concentrations exceeded those found in many mature forests. The soil was rich in microbial activity, indicating a healthy and productive ecosystem. One of the most notable discoveries was a massive fig tree at the center of the plot. Its trunk was so large that 3 people were needed to encircle it. The researchers calculated that this single tree stored more carbon than entire acres of typical secondary forest. The size and structure reflected long-term ecological stability. The fig tree's presence had broader ecological implications. Figs are considered keystone species, producing fruit year-round and supporting numerous animal species. These animals help disperse seeds, which accelerates natural regeneration and ecosystem resilience. The tree had become a central driver of biological recovery. The team also confirmed that the invasive African grass, which had previously dominated the area, had been eliminated. The orange waste had smothered it so effectively that it failed to re-establish, creating space for native vegetation to take hold. Wildlife returned as well. Researchers documented the presence of a teira, a large forest-dwelling weasel that requires mature, undisturbed habitat. Its appearance provided strong evidence that the area had transitioned from degraded pasture to functioning forest. These findings confirmed that the orange waste experiment not only restored vegetation but rebuilt complex, self-sustaining ecosystems, an outcome few conventional reforestation methods had achieved in such a short time. When the team published their findings in the journal Restoration Ecology, the scientific community was stunned. Here was evidence that agricultural waste, which normally costs money to dispose of, could create forest restoration results that surpassed anything achieved by traditional methods. The implications went far beyond just orange peels. The study suggested that secondary tropical forests, those that grow after the original vegetation has been cleared, might be far more important for fighting climate change than anyone had previously understood. Recent research has already shown that secondary forests absorb and store atmospheric carbon at roughly 11 times the rate of old-growth forests. Young, fast-growing trees are hungry for carbon dioxide, pulling it out of the atmosphere and locking it away in wood, roots, and soil. The orange waste experiment had created exactly this type of carbon-hungry forest, and it had done so at no cost. This was one of the few documented cases where carbon sequestration was not only free, but cost-negative. Instead of paying to remove carbon from the atmosphere, Del Oro had been funding conditions that would sequester large amounts of carbon for decades. The success of the Orange Peel project led researchers to explore similar strategies with other agricultural waste. In 2021, scientists from the University of Hawaii published findings from an experiment using coffee pulp to restore degraded land in Costa Rica. Unlike the orange experiment, this project was monitored from the outset. Researchers applied a 20-inch layer of coffee pulp to pastureland overrun by invasive grass and tracked changes over 2 years. Results came quickly. After 2 years, 80% of the treated area was covered with young forest canopy, with some trees reaching 15 feet in height. The control site showed only 20% canopy cover. Like orange waste, coffee pulp smothered invasive grasses and improved soil fertility. However, it also attracted different beneficial insects and supported a distinct set of native plant species. The experiment provided strong evidence that agricultural waste can accelerate ecosystem recovery, but it also emphasized the need for rigorous oversight. Different types of waste and land conditions may yield varied outcomes, making careful evaluation essential for broader application. The coffee research team acknowledged key limitations of their experiment. The method only worked in tropical climates with adequate rainfall to support rapid plant growth. Waste had to be free of pesticides and chemicals harmful to soil organisms, and application needed to occur far from water sources to avoid contamination. Researchers stressed that agricultural waste dumping must be scientifically guided and supervised by restoration experts. While the success of both the orange and coffee experiments gained international attention, many questions remained. Could this approach work in other climates? Would other types of waste have similar effects? What were the long-term impacts on soil and water quality? Studies began in dry forests, cloud forests, and tropical savannas using waste from crops like bananas, coconuts, and rice. But the central takeaway from the orange peel experiment was that solutions to land degradation could emerge from unexpected sources. 2 decades later, scientists recognized that what began as a waste disposal challenge had revealed a low-cost method for ecological restoration. Ironically, the project, once halted by Costa Rica's Supreme Court over environmental concerns, had become one of the most successful restoration efforts documented. Yet its success was tied to a unique set of local conditions not easily replicated. Costa Rica's stable sub-equatorial climate, with year-round temperatures near 82 degrees Fahrenheit and distinct wet and dry seasons, enabled rapid decomposition and plant growth. The decomposition needed to be fast enough to suppress invasive grasses before rot or pests developed. In colder or more extreme climates, results could differ. Rainfall also played a critical role. Costa Rica's wet season provided sufficient moisture for growth without leaching nutrients. In areas with either too little or excessive rainfall, the waste could dry out or create anaerobic conditions. Soil type mattered too. The test site had compacted but chemically sound pasture soil. In contrast, former mining lands or chemically polluted sites might respond poorly. Equally important, the orange waste had been processed to remove D-limonene and contained no pesticides, conditions not guaranteed with all agricultural byproducts. Researchers emphasize that this method requires scientific oversight and should only be applied where conditions match those that enabled its success. Even so, the findings are prompting new investigations into how citrus and other organic waste might help solve environmental challenges worldwide. The global citrus industry produces about 15.6 million tons of waste annually, with nearly half of all harvested citrus ending up as peels. Traditionally, this waste has been burned, sent to landfills, or processed into animal feed and pectin. Today, researchers are finding new ways to use this waste to solve major environmental problems. One promising innovation involves converting orange peels into clean biofuel. Scientists have developed a microwave-based process that breaks down peel cell structures, releasing oils that can be refined into fuel. This biofuel is carbon neutral, offering a renewable energy source without increasing net emissions. Compared to fossil fuels and wood-based biofuels, it is more sustainable and avoids contributing to deforestation. In Italy, designers from Carlo Ratti Associati created the Feel the Peel project, a machine that transforms orange peels into 3D printed drinking cups. The 10-foot-tall unit holds up to 1,500 oranges and produces cups on demand from the same fruit used to make juice. The cups are biodegradable, creating a closed-loop system with zero waste. Spanish researchers are also using citrus waste to develop biodegradable packaging. Specially engineered microbes convert orange peels into monomers, which are processed into plastic alternatives like bottles and containers. These materials are compostable and made from zero-cost raw inputs. In Milan, the startup Krill Design created the Omi lamp, manufactured with 3D printing using bioplastics derived from 2 Sicilian oranges. The lamp is fully compostable and highlights how food waste can be transformed into valuable consumer products. In Japan, researchers at the University of Tokyo developed building materials from food waste, including orange peels. By vacuum drying and heating powdered waste with binding agents, they created materials stronger than concrete, resistant to rot and mold, and suitable for outdoor use. These innovations reflect a broader shift in how waste is viewed. Inspired by the orange peel forest experiment, scientists and entrepreneurs are reimagining waste as a valuable resource. Despite facing legal and institutional resistance, the original project proved that restoration can come from unconventional ideas. Today, with climate change, deforestation, and food waste at crisis levels, the experiment remains relevant. Jansen and Hallwalks, now in their 80s, demonstrated that thinking differently about waste can yield powerful environmental solutions once dismissed, but now at the forefront of sustainable innovation. If you enjoyed today's video, please give it a like, and don't forget to subscribe to the channel. Your support means a lot to us. Thank you so much for watching, and we'll see you in the next video. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.